So in this video, we want to talk about the different types of numbers, namely the different sets of numbers. Remember, the definition of a set is just a list of terms, variables, or things. That's a generalized definition. So, looking at the fingers on your hand, if you start counting from 1, 2, 3, 4 onwards, we call those numbers the natural numbers. So listing it in terms of a set or putting it, we would have 1, 2, 3, 4. These three dots in mathematics means something goes on forever. So the counted numbers or the natural numbers is the numbers 1, 2, 3, 4 up to infinity onwards. Now the whole numbers is the natural numbers with the addition of 0 to the list or to the set. My mistake. 4 dot dot dot. So the whole numbers is 0, 1, 2, 3, 4. Pardon this part of the curly bracket. For some reason, I get trouble to write that part. Like my brain is a malfunction. So now we have the set of integers. What is the integers? Well, that's when you take the whole numbers and you include the negative numbers. So -3, -2, -1, 0, 1, 2, 3, 4 onwards. So remember, these dots mean goes on forever. So I'm just put dot 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 means goes on forever. The correct way to say this is it goes to infinity. You could just go to infinity, but in layman's term or in common terminology, just interpret it as you could keep counting. You can keep counting. So the natural numbers we say is 1, 2, 3, 4, 5, 6, 7, 8 onwards. I think about it like how you count with your hand. You start from 1 and go upwards. Those are the natural numbers. The whole numbers is 0 with the addition of the natural numbers. And the integers is the whole numbers with the addition of the negative numbers. So let's see this relation here. We see the natural numbers contained here, and we see the whole numbers is contained there, the negative integers. So now we have the set of fractions, but before we talk about the set of fractions or rationals. Q is the symbol. The symbols I'm using here is the symbols in mathematics for these sets or for these numbers. Q or the set of fractions is written as some number A all over B such that A is equal A belongs to the integers, B belongs to the integers, and B is not equal to 0. So the set of fractions is written as some integer all over some integer where the numerator is an integer and the denominator is an integer. And the denominator cannot be 0 because when you have divide by 0 in mathematics, you end up with infinity. That will be discussed in later videos. when we doing limits. When we start to talk about limits, that divide by infinity would be discussed, but just know for now, you can't have a fraction where divide by 0 or you have a 0 in the denominator. So let's see how technically. So let's let's use this. So if I put all over 1, 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 we could do the same thing here. We could do the same thing here. But I did it with this set because the natural numbers and whole numbers are contained within the set of integers. Or we could say the natural numbers is a subset. Let me use the proper notation. Is a subset of my bad. Is a subset of the whole numbers as seen here. Then the whole numbers is a subset of the integers, and the integers is a subset of the rationals. Now we have something called the irrationals, q prime or q complement, which is numbers that cannot be expressed as fractions. Some examples are pi, e, root 2, root 10, root pi. There are infinitely many irrationals. This is just what I could think of off the top of my head. Dot, dot, dot. Okay, let me just neaten that out. So infinitely many irrationals. So let's draw a Venn diagram. Recall a Venn diagram is a diagrammatic representation of sets. Useful information can be deduced from Venn diagrams, which will be discussed in the next video or upcoming videos. So let's see how these types of numbers, or using mathematical language, these sets of numbers relates to each other, and how they are how starting from the natural numbers to the rationals, it's contained within each other. It's like, I don't know if you guys know about Russian nesting dolls. It's something like that. So we start with the natural numbers, and then we have the whole numbers, then we have the integers, and we have the rationals. Close enough. Then we have the rationals, and things that cannot be expressed as fractions, irrationals. And all these different types of numbers together, the universal set, or the set that contains all these sets, is called the real numbers. So the real numbers are all these different types of numbers. The natural numbers, the whole numbers, the integers, the rationals, the irrationals. Let's see this on a number line to make some sense of the real numbers. So I'm just going to use -1, 0, and 1, and 1. So let's just say here is -1/2. Here is a half. Here Looks like 1/4. Here could be -1/3. There are infinitely many real numbers between any two integers on a number line. So that's something to ponder there. You could check this between any two integers. You could do what I now do here, and you would find yourself, you could always come up with some number that it will blow your mind. It will blow your mind. Look here, I could see here is 9 on 10. And you could keep doing it. So the set of real numbers could be expressed in set notation as N union W union C union Q union Q complement. Now the union would be discussed in the next video, but it just means the set of real numbers is all of these numbers combined in layman's terms, or in common term, or in plain English. One thing that you might see in some textbooks is that the set of integers could be split into the positive integers denoted by C positive, which is 1, 2, 3, 4, ... and the set of 0 positive integers and the set of negative integers, C negative, denoted by ... -3, -2, -1, 0. Meaning infinitely many negative integers from this side to 0. So just thought that would be useful in case some of you guys see this notation in textbooks. But I just liked it as in take the union of both of them, and this is what's happened. Now I mentioned things like union over here that will be discussed in the next video, which is operations on sets. If you like the content, please like and subscribe. If not, thank you for watching still.